So, you've decided to use Hadoop in your organization. As you may have noticed, that's not the last decision you'll have to make when it comes to Hadoop. Determining which execution framework to choose, or even how to implement one, becomes extremely daunting as these details evolve and mature with each passing day. Decisions are required through every step as you collect, prepare, blend, transform, and distribute data. SyncSort has developed the intelligent execution layer that allows users to design sophisticated data transformations focusing solely on business rules, not on the underlying platform or execution framework. Intelligent decisions to optimize the job at hand are made on the fly based on criteria such as data volume, specified transformations, and available memory. No need to worry about mappers, reducers, big or small data sets. As a fervid contributor to the Hadoop ecosystem, SyncSort will keep up with the emerging technologies and incorporate their processing capabilities into the intelligent execution layer. Kick back, relax, let SyncSort perform all the heavy lifting. Let's take a look at how it works. Here's a simple example of a DMXh job showing a join. After creating the task, just specify the files from HDFS as your left and right sides of the join. If you haven't loaded the data yet, DMXh provides one-step native connectivity to all sources such as Oracle, Teradata, Netezza, Greenplum, and Vertica. You can even blend in legacy data sources like the mainframe. Next, define the join criteria by dragging and dropping the columns into the middle. Specify your join type of inner, left, right, or in this case, full outer join. Once the join criteria section is complete, indicate where you want your output to go. You can also choose to define any field level transformations at this time with a reformat. This example is a change data capture, or CDC, determining the differences between two data sets. I'm comparing transactional data from my mainframe with data from my Teradata Enterprise Data Warehouse to see which records need to be inserted, updated, or deleted. Remember, while designing this job, I never had to think in terms of where I was going to deploy or execute. Go ahead and run it now. It doesn't matter if one side is large and the other side is small, or both sides are large or both sides are small. DMXh can run standalone on a Linux or Windows machine spectacularly with its highly performant runtime engine, or deploy to your Hadoop cluster and watch it decide to run a MapReduce job. Decide if it's a map side join or a reduce side join. The DMXh engine runs seamlessly within many typical execution environments to hypercharge the processing power for many common data processing tasks such as joins, aggregations, and sorts. After it finishes executing as a MapReduce job, you can inspect the log for details and browse the final results directly from the GUI. Future-proof your organization and Hadoop cluster against the ever-evolving Hadoop ecosystem. MapReduce is the incumbent, but Spark and Tez are rapidly gaining ground. What's going to come next? Let SyncSort solve the technical challenges and let your developers solve the business challenges. Learn more about SyncSort DMXh or take it for a test drive today at syncsort.com/try.